All right, guys, we're going to do a little bit of an introduction to limits here today. And so here are some ideas that we're going to talk about. It says, suppose you're asked to sketch the graph of the function f given by f of x equals x cubed minus 1 over x minus 1. Now, one of the things we've learned is that this function is undefined when x equals 1. And that's because when you have a 0 on the bottom of the fraction, the function is considered undefined. So you guys are pretty good now at this point at knowing that the value x equals 1 is not part of the domain of the function. So it says for all values other than x equals 1, you can use standard curve sketching techniques. That means that we could plug in any value for x other than 1 and generate an f of x or a y value and then plot that point on the graph. But it says, however, at x equals 1, it is not clear what to expect. So we want to talk a little bit about, and it's an interesting idea to think about what happens as we get closer and closer to the value of x equals 1. So here it says, to get an idea of the behavior of the graph of f near x equals 1, so as we get close to x equals 1, you can use two sets of x values. One set that approaches 1 from the left, and one set that approaches 1 from the right, as shown in the table. So here's our x values, and you can see we start out not super close to 1, 0.75, and then we go to 0.9, 0.99, and then we're getting super close here, 0.999. And here's the corresponding f of x, or y, values. We get 2.313 when x is 0.75, and then 2.71, 2.970, and here we get 2.997. Then if you look as we get closer and closer to 1 from the right, so we start at 1.25 and then work our way closer and closer to 1, 1.1, 1.01, 1.001. You can see what happens, and it looks like we start at about 3.81 here, and then it starts to get closer and closer to 3. So if you had to look, remembering this function is not defined at x equals 1, but it kind of makes sense to think about if we squeeze it together, it looks like the function is approaching, or f of x is approaching 3 from both sides, and this is the idea of a limit. And so here's the graph of f. This is a parabola, and it has a gap at the point 1, 3. So here's where the function is undefined. You see that open circle, and it says although x cannot equal 1, you can get arbitrarily, and that just means as close to 1 as we want, so we can approach it from this way. This is approaching from the left, and we can approach it from the right and get as close as we want to that open circle there. And it says using limit notation, this is notation we'll get really used to. It says the limit of f of x as x approaches 1 equals 3. Here's the sentence I just read. The limit of f of x as x approaches 1 is 3. So again, limit of f of x is this part. As x approaches 1 is right here. That limit is equal to 3. And that means that as we get closer and closer from this way and closer from the left side, we get as close to 1 as we want. And we get 3. This discussion leads us to an informal. So this is not the official definition of a limit, but gets you an idea of what a limit is. It says if f of x becomes arbitrarily, again that just means as close as we want it to a single number L, so in our example L was equal to 3, as x approaches C, so we were approaching the number 1 from either side, the limit of f of x as x approaches C, so in our case as x approaches 1, that's a 1, it equaled 3. It was as we got closer and closer to 1, both from the right side and the left side, our limit was approaching 3. So here's another example. It says evaluate the function f of x is x over square root of x plus 1 minus 1 as x approaches 0. Now again here, if you look, the reason this function is not defined at 0, right? 0 plus 1 is 1. The square root of 1 is also 1. 1 minus 1 is 0, so when we put in a 0, it's going to give us a 0 on the bottom, and we can't have that. So here's again the idea. X approaches from the left, x approaches 0 from the right, and you can see we're approaching 2 in both cases, and so that is the idea of a limit. So the limit of f of x as x approaches 0 is 2. And here it is on the graph as x approaches 0 from this way, and this way we're approaching the number 2, but you get an open circle there, and that's the idea of the limit.